a new chapter about password storage. So this time we are going to go through these two paragraphs. If you're new to this channel, first we read the left part, which is the original. Here is my version of it, which is this time 44% shorter. So, as the majority of users will reuse passwords between different applications, it is important to store passwords in a way that prevents them from being obtained by an attacker, even if the application or database is compromised. As with most areas of cryptography, there are many different factors that need to be considered, but fortunately, the majority of modern languages and frameworks provide built-in functionality to help store passwords, which handles much of the complexity. This cheat sheet provides guidance on the various areas that need to be considered related to storing passwords. In short, use bcrypt unless you have a good reason to, which is a library for encryption. Set a reasonable work factor for your system. I'm not sure what it is, actually, we can check it. Use a salt. Modern algorithms do this for you automatically. So it's basically some random string that you generate for each password, and you prepend password with it, or you append to the end of it. And you can add a separator like a comma or dot or colon or something. Consider using Pepper to provide an additional layer of security. So Pepper is just like salt, except it's not stored. So salt, you can store it in a database, and Pepper is stored in the code of your web server, for example. So it is stored separately from the salt. So even if the database is compromised, the attacker still is not able to figure out the original password so easily, even if they are hashed. Background. So hashing versus encryption. What's the difference? Hashing and encryption are two terms that are often confused or used incorrectly. The key difference between them is that hashing is a one-way function, i.e. it is not possible to decrypt a hash and obtain the original value, whereas encryption is a two-way function. So you can encrypt something and then you can get back the original value. In most circumstances, passwords should be hashed rather than encrypted, as this makes it difficult or impossible for an attacker to obtain the original passwords from the hashes. Encryption should only be used in edge cases where it is necessary to be able to obtain the original password. Some examples of where this might be necessary are if the application needs to use the password to authenticate against some sort of external legacy system that doesn't support SSO, which I believe stands for single sign-on, which is the thing you use when you have this Google pop-up and you can select an account. So that's the SSO. If it is necessary to retrieve individual characters from the password. The ability to decrypt passwords represents a serious security risk, so it should be fully risk assessed. Where possible, an alternative architecture should be used to avoid the need to store passwords in an encrypted form. This cheat sheet is focused on password hashing. For further guidance on encrypting passwords, see the cryptographic storage cheat sheet. Now this shorter version. Most users reuse passwords between apps, so store them securely to prevent theft by an attacker, in case of either app or database being compromised. Most modern languages and frameworks have built-in password storage functionality, which reduces the complexity of your authentication business logic. TLDR, use bcrypt, which is the library, set a reasonable work factor for your system, use a salt, modern algorithms do this for you, or use a Pepper additional security layer. Hashing versus encryption. Hashing is not encryption. Hashing is a one-way function, so no decrypting. Encryption is a two-way function, so we can get the value back. Passwords should, in most cases, be hashed. Very low chance of figuring out the original password by an attacker. Encryption, use only in edge cases where you need to get the original password back. For example, an app uses password authentication against an external legacy system with no SSO support. You need the original password. And decrypting passwords is a security risk, so it should be fully risk assessed. Seek better alternatives to avoid storing encrypted passwords. More info on encrypting passwords, cryptographic storage cheat sheet. And that is it for this video. Aha, right. That is not for it for this video. Let's see what the work factor is. So a number of iterations. Okay, so when you generate hashes, the work factor is the number of iterations. So the more iterations you set, the more time hashing a given password will take, but it will also be stronger. So, but on the other hand, you do not want to set like 1 million iterations, because you might spend half an hour hashing one freaking password for one user. So, and you have lots of users. So yeah, that's basically, yeah, it depends on what kind of server you're running on, if it's a beast or not, and what kind of security you're aiming for. So thank you very much for watching. This is it for this video, and I will see you in the next one very soon.